All right, so next we're going to look at a very, very powerful and important theorem in Unit 5 known as the factor theorem. Okay, we're going to be using this factor theorem quite a bit in a couple of different lessons throughout this unit. Very important. It's based off of those linear factors. And just to kind of set up what this box right here, the expression x minus a being a factor, if and only if the value of a is a 0 of the related polynomial function, blah, 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 blah. Looks very convoluted and annoying. Let me just put it to you this way. Pretty much what this problem in this type of factor theorem allows you to do is that if you can work, let me go back here. Remember this problem right here. See those zeros that I circled right over here? 0, 3, and -5. If those are zeros, in other words, if we were able to look at the problem that was factored already and come up with the zeros, we should be able to go the other way. In other words, if I gave you the zeros of 0, 3, and -5, we should be able to go back and write this, write that, and write that, and be able to multiply all that together to give us the polynomial that would give us that particular function. That's pretty much what's going on here with the factor theorem. That's how we use it. So looking at this problem with that kind of a lens, it starts to make sense of what they're trying to do. So if I'm looking at this problem, let's write a cubic polynomial function in standard form as zeros of -2, 2, and 3. Okay? If they know that those are the zeros, the part that they're kind of not writing here is they're saying, well, if I were to solve this problem, say one of them is at -2, and x is at 2, and x is at 3, which means that each one of those would have factors that go with it. Look at those linear factors. Look familiar? If this was from the front side of this note sheet, I would have made you graph that by plotting those zeros, and then graphing all the points in between the zeros. But now what they want to know is instead, what would it look like the other way around? Now, here's the part where it might get a little bit confusing for some of you guys to read, and I don't blame you. This part here, the textbook does an awful job of trying to explain this to you and explain the multiplication. First off, let me just put it to you this way. If I were to give you 3 numbers and I asked you to multiply them together, here I'm going to go. I'm going to write them in here in green. Has nothing to do with this problem, but it's an analogy for this to help you with this kind of multiplication. I'm going to give you 3 times 2 times 1. What's the answer? 6, right? Oh wait, I didn't mean to write it like that. I want you to do 1 times 2 times 3. What's the answer? Oh wait, it's 6. No, wait. I want you to do 2 times 1 times 3. What's the answer? You're getting the idea, right? Not only does it not matter what order I give you the numbers, it doesn't even matter what order you decide to multiply those numbers. If you want to do 2 times 1 times 2 times 1 first, then multiply by 3, you get the same answer as if you did 1 times 3 first, and multiply that answer by 2, right? We call that the commutative property and the associative property, right? Those were kind of a big deal back in your early algebra days. Well, they're back here. So what they're trying to show you here that might not be all that obvious when you're trying to read it is that what they did is they decided to multiply those two together first. And that's why you have this right here. First, outer, inner, last. Okay? What also is not so obvious is what they decided to do right here. Okay? And multiply those together. What you're looking at down there might not be something that you're used to seeing. In fact, let me get rid of it. You might need a separate sheet of paper, or if you're just paying attention to the video, take a look at what I would do on this problem. And stop me if you've heard this one. I sound like a really bad comedian. I am a very bad comedian, but let's just bear with me here. Do you remember when you would multiply polynomials together and you'd do that matrix type move and you'd make like this rectangular array? This is how I would have shown you to do this problem if I was sitting in front of you right now. And then I would grab the x and the 2, put the x and then the positive 2. You know what I'm hearing probably right now in that classroom? You're probably hearing a lot of, oh yeah, I remember this, I remember this. And then how often did that teacher have to correct students, and maybe this was you, that when it came to fill in this first box, you made this mistake. X squared. Whoops. You know why you did that? It's because you see a 2 here, you see nothing there, and you put that 2 there. So maybe do this before you start filling in numbers there, is possibly put a little 1 right there, put a little 1 right there, and then if you feel like to put a 1 coefficient right there, go ahead and do that too. Now start filling those in. It makes a lot more sense to say, oh yeah, that's x to the 3rd. And then we have minus 5x squared. And then plus 6x to the first. And then down here we're doing 2 times all 3 of those things, right? So then 2x squared minus 10x, and then we have plus 12. And then what we're looking for to simplify the expression is we're looking for like terms. Combine like terms. Remember, combining is just a fancy word us mathematicians use for you to add 2 things together. Always add. So can you see why this final answer right down here has x to the third? Because there's your x to the third right there, nothing to combine it with. Look at that there in yellow, negative 5x squared and 2x squared. Combine those together, 2 minus 5 takes you down to a negative 3x squared. And then negative 10 plus 6 would take you to a negative 4x. And then 12, all by its lonesome there, there's the answer. So I would love it if you guys would handle that multiplication just like that. Okay? So, the sample problem right down here. Do you notice that it actually wrote down negative 2 twice? They're expecting you to write the negative 2 twice because they want a 4th degree polynomial. Okay? So first step, let's write out those zeros. So I have x with minus 2 as a negative 2 as a 0. Wouldn't it have to be x plus 2? Followed by a second x plus 2. And then if 2 is a 0, then opposite game again. And then opposite game again. If the last 0 is a positive 3, we're going to write negative 3. So, time to multiply. How shall we multiply this together? How about, let's go ahead and multiply these 2 together. Then, let's multiply these 2 together. Does it make sense here in the first case that we should have x squared plus 4x plus 4? How about the other one, the green one? Take a look at that. How comfortable are you with that one? Works for me too. Now it's time to multiply those together. Can we use that same rectangular array that we've seen right here? In fact, it's not actually going to be a rectangular array for all this distributive property we're going to do. We're actually going to make a perfect 9 by 9, or a 3 by 3, 9 squared array. Now, Mr. Cook is mega lazy here. So lazy, in fact, that when it comes to making that rectangular array, when it comes to the multiplication, I like just keeping the second one right where it's at, and then just basing my columns off of that. Okay, great looking lines, straight lines, right? And then I like to write the first one just along the side, just like this. Okay, and then there's my rows. Now let's fill those in. Oops! Make sure we do this first. How about you go ahead and put a invisible 1 right there so it helps minimize some of those mistakes. Okay, let's fill those in. I'll pause it. You write. Take a look at the answer in a moment. Cool, so look at all that. How'd you do? Do you see the nice little pleasing diagonal nature of the like terms? There's one set, there's another set, and there's a third set right there. Okay? Just keep this in mind. When you're filling in the spaces, make sure that you're changing the exponent using your exponent rules, right? A square times a square makes a 4th power. But then when you're pulling these out of this rectangular array, remember you're combining like terms. When you combine like terms, you do not change those exponents. So, looking at what we have here, x to the 4th, highest power right there, right? So now I have x to the 4th, and then we combine a 4x to the 3rd minus 5x to the 3rd. So shouldn't that make negative 1x to the 3rd? And now looking at the rest of those, I have a 4 plus a negative 20 plus a 6, aka if you want to add the 4 and the 6 together to make 10, 10 then minus 20 should put us at a negative 10x squared. The negative 20 plus the 24, shouldn't that put us at a positive 4x? And then last but not least, we got our 24. I'm going to pause it right now to check my work, make sure there's no mistakes. Alright, well, I think it's looking pretty good. If I made any mistakes anywhere, please, 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 students, point that out. Make sure the rest of the class knows that, but I think I'm alright. Let's take a look at one last thing here. Do you notice that when we looked at this quartic polynomial, a 0 of -2 was actually being used twice? We call that in the math biz multiplicity. So in other words, -2 occurred multiple times, and then 2 and 3 occurred only one time. Okay? Visually, multiplicity will have a distinct look to it. Multiplicity, what I found in the past is a lot of times students can get kind of hung up on it and be a very complicated topic here. It depends, you have to juggle a lot of things to understand multiplicity and have a full grasp of it. And it really won't really come into focus until really we talk about the fundamental theorem of algebra as well here too. So let me just say this about multiplicity. If you end up finding multiple solutions, I just expect you to state that when I'm asking for the solutions here. So when you're looking at this problem, right down below here, just have this approach. I'm not trying to get you to reinvent the wheel. What are the zeros of x to the fourth? F of x equals x to the fourth minus 2x cubed minus 8x squared. Please treat this as being absolutely no different than this problem right here. See how it's just a factored form? The only difference between this guy right here, when you factored it, and this guy right here, is that now, after you factored it, set them equal to 0 and just state what those zeros are. That's what I want you to do. Okay? The multiplicity stuff I'm not too concerned about right now at this point. Okay? So when we look at this problem right down here, what are the zeros? The zeros, all you have to simply do is see that f of x, just set it equal to 0. That's step 1. I'm going to copy down the problem, not do anything fancy here yet. Minus 4x squared plus 4x. All I'm going to do is going to take out the GCF, and let's solve this by factoring. GCF here is x. So then I would have x squared minus 4x plus 4. X is still there. And then I believe we can factor this guy right here. Here's how this one, whoa, the board's acting kind of squirrely with me, so bear with me here. Wow, it is acting really squirrely. Let me reset this thing. Alright, I didn't sort it all out, but I went ahead and just filled in the rest of it right there, right? Wouldn't -2 times -2 give us a positive 4? And then -2x, and then an inner -2x would combine to give us a -4x right there. So, we'd set each one of those equal to 0. And it's still acting kind of squirrely here, so bear with me. X could be equal to 0. Isn't that coming from this guy right here? Okay. Next, we'd say, okay, x minus 2. You could be equal to 0. Solving that algebra problem by adding 2 to both sides. X then would be equal to 2. So now I have 2 answers. The third answer, wouldn't that one be exactly the same because we have the same linear factor right there? So we just get an x equals 2 a second time. Okay? Let's temporarily ignore that right there. All I want you guys to be able to do, I'd be happy if you're able to look at those and be able to tell me those zeros. Okay? So that's about it. When you look at those homework problems too, by the way, if the question's asking you for multiplicity, all you have to do is just say that the multiplicity is that x equals 2 occurred 2 times. That's you stating the multiplicity there. X equals 0 was 1 time. Okay? Like I said, that board's acting kind of funny here, so I think it's a sign for me to quit. Alright? So, there's 5-2 for you. Good luck, everybody. Email me or call if you have any questions.